They want us to look at this example. So it's on Laplace. It doesn't involve a step function, though there's something we need to discuss. So notice that the initial conditions here, we don't start at 0. The initial conditions start at 2. So question is, how do you handle such initial value problems? Are you able to get me? Can we continue?
Yes, we can continue.
Okay. So someone, one of you sent me this question. It's actually from one of these previous year's tests. So I thought we should do it together. So how do you do this? So because, when you're dealing with Laplace, when you find the Laplace of a derivative, it's going to have these initial conditions at 0, that is. So you have to find a way of having your initial conditions start at 0. So what do? Introduce another variable, say t of tilde. Let's call it t of tilde. So this variable is equal to this variable t, this question, minus 2. So that when this when t is 2, t tilde is 0. And so we can change the nature of this function. It will become, so this tilde is associated with y tilde, a new function called y tilde. So this ODE will become y double prime, so y tilde plus 2 y tilde prime plus 5 y tilde is equal to, so this is t minus t tilde, because t minus 2 is t tilde. So this will be 50 t tilde. And what will be the initial conditions? So the initial conditions are going to be that y tilde at 0, not 2, at 0, when t tilde is 0, is going to be equal to -4. And y tilde prime of 0 is going to be equal to 14. So what we've done is changed it so that our initial conditions are at 0. We can solve this, then come back to this just by changing the variable. Is this okay? Comments?
Sorry, I didn't get why we are changing it to t tilde.
Because the reason is when we're finding the Laplace of a derivative, take the second derivative, y double prime. This is equal to s squared, the Laplace of y minus s y of 0, then minus y prime of 0. So you see, this is the reason we're changing it to t tilde, because of this. Because the Laplace of a derivative is given in terms of the Laplace of y and y of 0 and y prime of 0.
Oh, okay. Thank you, sir.
Yeah, yes. Okay, so if this is okay, then we have to solve this. So we've just changed the nature of this equation to this. We'll solve this, then come back to this just by replacing the variable. So next page, we go ahead and solve. So what I'll do is, because, so I've changed the equation, but I don't want to continue writing it because it will be too much work. So I'll just write it as y double prime plus 2y prime plus 5y is equal to 50t. And I'll say y of 0 is -4 and y prime of 0 is 14. So I'll solve this, but I know my original one is this, so I have to go back. So I do this because I just don't want to continue writing y tilde to lessen on the work. So if you are agreeable, then we can solve this one. So these are usually long, but I hope this one won't be too long. So let's start. So we're solving this using Laplace transforms, right? So we apply Laplace both sides of the equation. Laplace is a linear operator, so it can distribute over a sum. Five Laplace of y then is equal to 50, then the Laplace of t. So this is what we have. So what is the Laplace of y double prime? So it is s squared Laplace of y minus s y of 0 minus y prime of 0. That's the first one. Second term is going to be plus 2, so we have to include the 2. Then s Laplace of y minus 2 y of 0. And the second term, the fifth term, the third term, we don't need to do anything. It's just this. And then this would be 50. The Laplace of t is 1 over s squared. So I'll just say 50 over s squared. Okay. So now I can replace what my y of 0 and y prime of 0 is. I can also factorize Laplace of y. So first, factorizing Laplace of y, I have Laplace of y. So we have this term. So from there we get s squared. From this term we get plus 2s. From this one plus 5. This is going to be, because y of 0 is negative 4, so this is going to be plus 4s minus 14. Y prime of 0 is 14, so minus 14. We also have this one. So this is y of 0 is negative 4, so plus 8. Yes, plus 8. Yes. And then is equal to 50 over s squared. So this is Laplace of y, and then s squared plus 2s plus 5 is equal to, I take this the other side, so it's 50 over s squared, then minus 4s, negative 4 plus 8 is negative 6, so this will become plus 6. We can divide both sides by s squared plus 2s plus 5, so that we have that Laplace of y is equal to, so it's going to be 50 over s squared, then s squared plus 2s plus 5, then minus 4.
You're on mute, sir.
Sorry about that. So it's 4s over s squared plus 2s plus 5, then plus 6 over s squared plus 2s plus 5. Okay. And what we can do is we can write this under one single denominator. I think that will lessen our work. So I can say Laplace of y is equal to, the common denominator is s squared then s squared plus 2s plus 5, like this. Then we start with this term. So this into this we get, so it will be negative 4s cubed. And then this one we get plus 6 s squared, then that one, so plus 50. So that we just have a single fraction. Is this okay? Do we have any comments? There are no comments, then you know straight away that we have to resolve these into partial fractions. So what are we going to have? This is our denominator. So we have this s squared, we know how it's going to become. Then this is a quadratic which we can't factorize because, yeah, because its discriminant is less than 0. So let's check b squared minus 4sc. So we have b is 2, so 4 minus 4, a is 1, and c is 5. So we get 4 minus 20, yeah, which is less than 0. So we can factorize this. Therefore, to decompose this into partial fractions, this is going to become, so we're going to have negative 4 s cubed plus 6 s squared plus 50 over s squared, then in brackets s squared plus 2s plus 5 will become a over s plus b over s squared. And then for this quadratic, you have c s plus d over s squared plus 2s plus 5. If we get so what our numerator is going to be, so that we compare with this one, we're going to have s squared plus 2s plus 5, and then so we're going to have a s, then s squared plus 2s plus 5 plus b s squared plus 2s plus 5. Then I'll write my c down here, so plus cs plus d, then s squared. So this is also over s squared plus 2s plus 5. Okay. So if this is what we have, then we know that this numerator, so the numerator, we compare the numerators with this one. So we have that a s squared plus 2s plus 5, then plus b s squared plus 2s plus 5 plus cs plus d s squared is equal to minus 4 s cubed plus 6 s squared plus 50. Okay, so our task is to find what our a, b, c, and d are. So like we did it yesterday, we can collect the like terms, open up a bracket, collect the like terms, and then equate with the coefficients on the right hand side. So opening up the brackets, we have a s cubed plus 2a s squared, then plus 5 plus 5as, sorry, 5as. So that's the first part. The second term becomes plus b s squared plus 2bs, then plus 5b. The last one, plus c s cubed, then plus d s squared. So this is equal to negative 4s cubed plus 6s squared plus 50. On the left hand side, we collect the like terms. So we have a s cubed and c s cubed. So we have a plus c s cubed. S squared, we have 2a, we have b and d. So we have 2a plus b plus d, that is s squared. For s, we have how many? We have this one and this one. Yeah, we only have 2, so it's plus 5a plus 2b s. Then the constants, we have 5b, only 5b, right? Yes. So plus 5b is equal to minus 4s minus 4s cubed plus 6s squared plus 50. So it's just a matter of now comparing coefficients. So we start with the constant. On the left, the constant is 5b, and on the right, the constant is 50. So this is equal to 50, meaning that your b is equal to 10. So we're done with our b. Let's go to the coefficient of s. The coefficient of s on the left-hand side is 5a plus 2b. On the right-hand side is 0, so this is equal to 0. We already know that our b is 10, so 5a, 2 times 10 is 20, 20 is equal to 0. Therefore, 5a is equal to negative 20. Divide through by 5. We get that a is equal to negative 4. How about the coefficient of s squared? So we have that 2a plus b plus d is equal to, the coefficient of s squared on the right hand side is 6. So it's 2a, b is 10, so plus 10. We have found a, so let's do this. I cancel this. So a is negative 4, so 2 times negative 4 is negative 8. B is 10, so plus 10. Then plus d is equal to 6. Negative 8 plus 10 is 2, so 2 plus d is equal to 6. Therefore, d is equal to 6 minus 2. D is equal to 4. So just remaining with C. And because, okay, yeah, let's find it. So for the C, we're going to say that A plus C is equal to, so A plus C is the coefficient of S cubed on the left-hand side. On the right-hand side, the coefficient is negative 4. So this should be equal to negative 4. My A is negative 4, so negative 4 plus C is equal to negative 4. So C is equal to negative 4 plus 4, and my C is equal to 0. So I found what my A, B, C, and D are. So I go back and replace. So what we had was that negative 4s cubed plus 6s squared plus 50 over s squared plus 2s plus 5 is equal to a over s plus b over s squared, then plus cs plus d over s squared plus 2s plus 5. So we found our coefficients. So this means that a was what, -4. So this is -4 over s. Our b was 10. So this is plus 10 over s squared. C is 0. And d is 4. So this is plus 4 over s squared plus 2s plus 5. This is what our Laplace of y is. Laplace of y. So before we continue, maybe I should pause and allow some questions. Is everything okay? Someone to say something at least. Anything, any comment?
We can proceed.
Okay. So if this is our Laplace of y, then we just need to find y, we just need to find the inverse of this. So before we find the inverse, I would just like to put this, the last one, these we can easily find the inverse. The last one, just to put it in a nice form so that we clearly see the inverse. So I'll say Laplace of y is equal to -4 over s plus 10 over s squared. I complete the square there. So this will be plus 4 over, so it's s.
Excuse, sir.
Yes?
Hello, sir.
Yes.
On C, is it CS
Yes.
plus D or what? Is
Yes,
that
it's CS
plus D?
Correct.
So what has happened to become 4 now?
Because
Where has
the
it
C
taken
is
S?
0. Because the C is 0.
Huh?
So 0 times S is
Oh,
0.
okay.
Yes, yes.
Okay, thank you.
So completing the square here, we get S plus 2S plus 1 squared minus 1 plus 5. Therefore, the Laplace of y is -4 over s, then plus 10 over s squared plus 4 over, so this will be s plus 1 squared, then this will be plus 4. Okay. Yeah, this looks good now. So y is going to be the Laplace inverse. So Laplace inverse of 4 over, or it's negative 4 over s, Laplace inverse of 10 over s squared, then plus the Laplace inverse of 4 over s plus 1 squared plus 4. So y is equal to, the first one, the Laplace of 1 over s is just constant, it's just 1. So this is just -4. So this is just -4. The Laplace of 1 over s squared is t. So this is just plus 10t. And for this one, last one, it looks like a sign. What we need is just a 2 here, so we can factorize a 2 and it's shifted by 1. So it will be plus 2e minus t, and then the sine of 2t. Yes. Is this correct? Any comments or questions?
It's correct, sir.
Okay. So, but we're not yet done. We just need to do that trick. So let me go to the first page. Yes. So this is what we had. So we had converted this equation from this to this, and we were dealing with this tilde. So we had removed them for convenience sake. So after we find this, what we've actually found, what we actually found is, so we go back to the tilde. So this is y tilde is equal to
Sorry, I
minus
wanted
4.
to ask, I joined a bit late, I had problems with my network. Is this the first example?
Yes. Do you need more help?
A little, but you can finish first.
Okay. So this is y tilde is minus 4 plus 10 tilde plus 2 e minus t tilde, then sine 2t tilde. Yeah, so this was tilde. So we have to go back to our t and our y. So we know that that t tilde is t minus 2. So what this means then is that y of t is going to be, which is the answer now to our original problem, is minus 4 plus 10, then t minus 2. So in place of t tilde, I put t minus 2 plus 2 e minus t minus 2, this, and then plus, sine, then sine 2 t minus 2. And this is now the answer to our original problem. Is this okay?
Yeah, it's all right. Yeah, so now I wanted to ask if it's possible for you to explain the beginning for me. Like I found you when we were finding the values for A, B, and C.
Okay, so this is the first page. So the first page, this is the original problem. So what we notice is that this is an ODE with initial conditions well and good. The only problem is that the initial conditions don't start at 0. We're not given y of 0 and y prime of 0. And that is a problem to us because we know when we are doing this Laplace, the Laplace of a derivative is always expressed in terms of initial conditions of y at 0. So we had to make this substitution. So we introduce another variable, say called t tilde. We say t tilde is equal to t minus 2. So that y becomes y tilde, and y tilde of 0 now will be minus 4, and y tilde prime of 0 will be 14 because of this substitution. So once we make this substitution, this problem is, the way this problem is phrased is now familiar because you have your initial conditions at 0. So you start working on this. So which one was the next page? I put my papers properly. Yes. So this problem, we just converted it. So we just removed the tildes for convenience sake. If you want, you can continue with the tildes, but it would be too much of writing. So for convenience sake, we just write it like this. So okay, let's solve this one. But meanwhile, we know we have to, this is our initial problem. So we'll cater for this when we're done with this one. So this one, again, it's the same procedure, apply Laplace on both sides. You get this. factorize Laplace so that you isolate the Laplace, then it gives you this. So this is not difficult, it's just a matter of a little algebra. And then this, when you write it under, you add them under a common denominator, you get this. So what you want to find now is the Laplace inverse of this. So you have to decompose this into partial fractions. So this was the work we were doing of decomposing. It's quite some work, but not too much. So we decompose it. So the decomposition is going to be like this. Or we need to find our constants, A, B, and C. And we found that our A was -4, our B was 10, our C was 0, and our D was 4. So that it looks like this. Yeah, so your A is -4, your B is 10, your C is 0, D is 4, so it looks like this. This now you can easily find the inverse Laplace. This one you just have to complete the square so that it looks like this. And then it's obvious now. Inverse Laplace of this one, -4 over S is just -4. The inverse Laplace transform of 10 over S squared is 10t. And the inverse Laplace transform of this is 2, then exponential minus t sine 2t. So once you're done with this, again, you just have to again remember that, oh, you had changed your problem. And so to go back to your problem, so this is what you found. So you just in place of t tilde, they put t minus 2. So this is your answer to the solution.
Sorry, sir.
Yes.
In the from the first page of the question, it
Yes.
was saying our initial conditions were such that is it y of 2 is equal to -4, and then y of 2, y prime of 2 again is equal to -14. Do we have a situation where the initial conditions may differ? I mean, they can ask for y of 2 and y of 3. And if that's the case, how do we deal with the tilde that we had introduced?
No. All differential equations don't come like that. So the number you have there will be exactly the same as the one you have there.
Thank you.
Yes. Good question. Shows that you're thinking. Okay, any other questions? Looks like everything is okay. And we've done about 30 minutes. So this one didn't take us a lot of time. Let's do another one. So let me just check for that problem. So let me just give me just a minute. Okay, I found the problem. So y of 0 is 0 and y prime of 0 is 4. Let's confirm. Yes. Okay. So let's solve this one. This will be the last example, and then for today, that is. So notice that it's got a step function, discontinuous function. So we already know how to find Laplace of the step function, so that won't be a problem. So to start, how would I start it? I would write this. I would say y double prime plus 9y. Can write this function in terms of step functions. So it's going to be 8 sine t, and then you're going to have 1 minus the unit step t minus pi. Yes. So because it's between 0 and pi, it's 8t, and it's 0 when t is greater than pi. So this is how it's going to be. And so y double prime plus 9y is 8 sine t minus 8 sine t, then unit step ut minus pi. So because once you have this, what must come into your mind is that you have to use the t shifting theorem. So I'll rewrite it in the following way. So this is 9y is equal to 8 sine t minus 8 sine. So instead of writing t, I'll say t minus pi plus pi, and then my unit step there. And so this is y double prime plus 9y is equal to 8 sine t minus 8. So we can use the identity for sine. So what do we get? So then write this in square brackets. So sine of a plus b is sine a cos b, and then plus, and then so it's going to be sine t minus pi, then the cosine of pi plus sine of pi, then the cosine of t minus pi, in brackets multiplied by the unit step. So u t minus pi. So this is going to be y double prime plus 9y is equal to 8 sine t. What's cosine of pi? What's the cosine of pi?
One.
Not -1.
That's -1.
Yes, -1. And the sign of pi is 0, right? So this will fall out and this will become plus. So I hope you know why this has become plus, because cosine of pi is -1. So this is 8 sine t minus pi multiplied by the unit step t minus pi. Okay. Is this okay? Any questions here? Okay, so if there are no questions, it's now time to apply Laplace transform, both sides of the equation. So this becomes, or this will become let me just find some light. It's too dark. Okay. Okay, so this will become Laplace of y double prime plus 9 Laplace of y is equal to 8 Laplace of sine t, then plus 8, then the Laplace of sine t minus pi, then the unit step t minus pi. Like this. So on the left-hand side, we know that Laplace of y double prime is s squared, then the Laplace of y minus s, y of 0 minus y prime of 0. So plus 9 Laplace of y is equal to right-hand side, Laplace of sine t is just, so this will be 8 over s squared plus 1, s squared plus 1. And the last term, so this is using the t shifting, so it's 8, then exponential minus pi of s, then over s squared plus 1. Okay. So this is fine. We can even factorize the Laplace of y. So what we have is that Laplace of y, then s squared plus 9. Y of 0 is 0, so this term will fall out. Y prime of 0 was 4, so this should be minus 4 is equal to 8.
Sorry, sir. Could you just go back on how you got 8e to the pi s and over this?
Okay, so this 8 is this 8. I just drop it. So this is the t shifting. So t shifting, you know, it will involve exponential to the power negative pi of s. So you're multiplying this exponential by capital F of s. What's the capital F of s? It's just the Laplace of sine t. So Laplace of sine t is 1 over s squared plus 1. So that's how you get this. Was that clear?
Clear.
Okay. So this is plus 8 e minus pi of s over s squared plus 9. No, plus 1, I'm sorry. So what we get is that Laplace of y is equal to, push the 4 the other side, then divide by this. So it's going to be 8 over s squared plus 1, s squared plus 9, plus e minus pi of s 8 . Is this okay? I think so. Next is decomposing into partial fractions. So we just need to compose this because these are the same. So what I will say is that 8 over s squared plus 1, then s squared plus 9 is going to be, if you decompose it into partial fractions, so these are quadratics and you can't factorize these. So it's going to be a s plus b over s squared plus 1, then plus cs plus d over s squared plus 9. So again, we just need to figure out what our a, b, c, and d are. If we get the common denominator here, we have s squared plus 1, s squared plus 9. Common denominator is as plus b, s squared plus 9. Then plus cs plus d, s squared plus 1. So this is what we have.
Sir, I have a slight question. I know it may be going back a bit,
Okay.
but I think I get confused on the A, B, the C, and the D. How do you, like here you're at AS plus, how do I know I'm writing AS plus B? And yeah.
So so
That's how I was like, I think I'm going back.
okay. So if you're dealing with quadratics, if it's a quadratic, then if you can't factorize it, if you can factorize it, then you're going to have linear factors, which becomes easier. But if you can't factorize it, then this should be a numerator. It should be of this form, AS plus B or CS plus D. So both of them I can't factorize. I have this. If I had something like, so to just move away a bit, if I had something like 8 over s squared minus 1, then s squared minus 9, then I know I can factorize this. So this is the same as s over s minus 1, s plus 1, then s minus 3, s plus 3. So this becomes, when you decompose into partial fractions, it's a over s minus 1 plus b over s plus 1 plus c over s minus 3 plus d over s plus 3. Yes.
Okay, I think I kind of get it now. Thank you.
Okay. So back to our problem. We want to find what our A, B, C, and D are. What's the easiest way to do this? How can we find this? Do we need to open the brackets? I think so. It looks safer for me. So let's try opening the brackets. So s times s squared is a s cubed. Then yes, then a times s. Okay, I've done this. Then b times this is plus b s squared. Then as times 9 is plus 9 as, and then plus 9b. The second term is so it's plus c s cubed, then plus d s squared, then plus cs, and then plus d. So this should equal to this numerator, which is 8. Factorizing, we get we get a plus c s cubed plus b plus d x squared, then plus, so this is 9a, right? Yes. So it's 9a plus c. S, then the constants are plus 9b plus d is equal to 8. Okay. So what do we get? So we get our solutions in pairs. So we start with the coefficient of a plus c on the right hand side is 0. So what you have is that a plus c is equal to 0. And this one is also 0. So 9a plus c is 0. So you can solve this simultaneously. How can we do it? We can subtract this equation so that we have a minus 9a, which gives us negative 8a plus 0 is equal to 0. So a is equal to 0. If a is equal to 0, then c is also equal to 0, right? Yes, because a plus c is equal to 0. So c is equal to 0. Okay. How about b and d? So we have that b plus d is equal to 0, and 9b plus d is equal to 8. So again, subtracting, we get b minus 9b is 8b, negative 8b, d minus d is 0, which gives us 8. So b is equal to negative 1. If b is equal to negative 1, then d should be 1 because b plus d is 0. So d is 1. Okay, so if this is the case,
Sir,
Excuse me, sir.
yes,
It isn't it's supposed to be positive, looking at the fact that we are multiplying by -1 down there.
so b plus d, that's the first part, is equal to 0 because the coefficient of a squared on the right hand side is 0. And then 9b plus d, which is the constant, is equal to the constant on the right hand side, which is 8. Oh, I get your point. Yes. So I was doing b minus 9b is negative 8b. This is 0. This will give me negative also. Yes, correct. So if this is negative, then, so cancel this, then b is 1, implying that d is negative 1. Correct. Thank you very much. So if this is your b and your negative d, then this, the thing you wanted to decompose into partial fractions, which was 8 squared, 8 over s squared plus 1, s squared plus 9 is actually, so a and c as 0, b is 1, so this will be 1 over s squared plus 1, and d is negative 1, so this is minus. Or let's leave it plus and write minus 1 over s squared plus 9. Okay, so that was good. That wasn't too much work. We go back to our question now. So done the partial fractions. This is where we ended. So let's just finish it off. So if that is the case, then what we have is that the Laplace of y is equal to, if you decompose this into partial fractions, it's 1 over s squared plus 1 minus 1 over s squared plus 9. this as the first term. The second term is e to the power pi s. Then you have again 1 over s squared plus 1 minus 1 over s squared plus 9. And then this one plus 4 over this squared plus 9. So if this is the Laplace of y, it means that you just change the marker. It means that your y is equal to, that is your y of t, the Laplace of this first part. So what's the Laplace of this? Anybody help us with the Laplace of the first term? The inverse Laplace transform, that is. It's not difficult.
Isn't it y of t?
The first term, so this first term, 1 over s squared plus 1.
I meant sine y of t.
Sine y of t. It seems complicated. So it's just sine of t. Yes, sine of t. How about this one? 1 over s squared plus 9.
That's 1 over 3 sine 3t.
Good. So it's minus 1 over 3, then sine 3 of t. So we've done this. How about this one? So how about this one? So this, we're using the t shifting. Can anyone take it up?
Could it be sine t minus pi?
Yes. So that's the first part. So it's going to be, you just have to compare it with this one. So you shift this one by t minus pi and then just add the unit step. So it's just going to be plus sine t minus pi minus 1 over 3 sine 3 t minus pi in brackets multiplied by the unit step, which is u t minus pi. And the last one is 4 over s squared plus 9. I can even write it here. Anybody to help with this one?
I think 1 over 12 sine 3t.
1 over 12. Why are you getting 1 over 12? We're multiplying 4 by 3. It's supposed to be, I'll write it here, it's supposed to be plus 4 over 3, then sine 3t. Yes, so we can write it. We notice that these two terms are same. So this is sine t. Negative 1 over 3 plus 4 over 3 will give me 1, right? 1, yes. So this is plus sine 3t, then plus this sine t minus pi minus 1/3 sine 3t minus pi, and then unit step. And this is our solution. If somebody asks you to write this without the unit step function, then it's going to look like this. So it's going to be in intervals, 2 intervals. So the first part has this, so it's sine t plus sine 3t. This also appears here, sine t sine 3t plus this, which is plus sine t minus pi, then minus 1/3 sine 3t minus pi. What are your intervals? So this one is for t between 0 and pi, and this one is when t is greater than pi. And that's your solution. Are there any questions?
How many marks do such lengthy questions hold or carry, sir?
Usually 15, 12 in the exam, that is, but more than 10. Are those fair marks?
Give it 20, sir.
Yeah, I think 20 is fair. 20 is fair. Okay, I think we should end here. Okay, see you next time. So testing is on the 21st. We can have another class on Friday. So so like I said, we've done everything at the class. Maybe we can solve 1 or 2 questions within an hour, and then next week, no classes, then test on the 21st. So we'll meet on Friday.